How you doing? This is going to be a flipped assignment on the classification matter. My name is Chad Houston. Please feel free to subscribe to my YouTube channel. If you're a student, your guided notes on this needs to be the definitions, the terms, and an example. So when we're talking about the classification matter is something that can take up space, has mass, and some people describe matter as material science, or they look at the matter of solids throughout history. And that's one really cool way to describe it. I will have this presentation for you. That's not how we are going to describe it. We're going to use the more classical definition of matter. So matter is anything that has mass, takes up space. An example of matter would be, for instance, the computer that you're on right now. Now, it's typically broken down into two different areas. We're going to look at pure substances first. Okay, so if we look at a pure substance is anything that contains only one type of matter. It's completely constant in its composition. So as an example, if this ring right here were pure gold, which it's not, that's an element, but if it were complete gold, or that would be a pure substance which we call an element. Or if we had, for instance, H2O, which is water, which is a compound, and we have pure water, that also could be a pure substance. When we're dealing with pure substances, there are two types. First of all, there are elements. This can't be decomposed into any other thing. It's the smallest distinguishable substance in nature. If I have an atom, which is the smallest distinguishable unit of, for instance, carbon, and an atom of lead, they're completely different. However, if I take a proton from the lead and a proton from the carbon, I can't tell where the proton came from. So all protons are, for the most part, the same. So the next part, and again, if an example of an element, anything on the periodic table. Now, while we're talking about elements, something that we're going to touch on real quick is allotropes. Allotropes are the same atoms, but they can have different forms. And we'll find out that they're called sometimes molecular elements. But so, for instance, oxygen can be in the form of O2, which is the oxygen we breathe, or O3. They're all the same element. They can make up a pure substance. Ozone is very dangerous at ground level, whereas O2 is needed for life. Now, an example of that is over here for Adam Smith. Here's an example of carbon, which we see right here, which is in a diamond. Okay, and you can see this. And if you see all of the bonds there, one of the things that you end up seeing is that that's why diamonds are so strong. However, we can also have another form of carbon, which is graphite, same element. And if you look here, notice here, now watch this, if I turn this to the side, there, you see how there's no bonds in between, they're like layers. That's why graphite sometimes is very slippery and can be often used as a lubricant. But depending on the direction, it could also be very strong as well. So this would be an example of an allotrope. So both of these are pure substances. They're both carbon atoms, but they're arranged differently in space, and that's what makes up an allotrope. So like graphite and diamond would be an example. Okay, so those are allotropes. The other types of pure substances are called compounds and molecules. So any substance that can be broken down to elements by a chemical process. Elements that make up compounds have different properties than the compounds themselves. Again, going back to water, H2O, you can imagine that hydrogen and oxygen by themselves are very flammable and explosive, but with water, H2O, that means every compound of water is the same makeup. And what we end up finding is that it has the properties of water are very different than the elements that make them up. Now, what's the difference between compounds and molecules? It's a fine line, but here it goes. Compounds are made up of two or more different types of elements. Molecules could be two or more different types of elements that are the same or different. Okay, so two or more elements are same or different. Molecule. So for instance, NaCl could be a compound and a molecule. O2, N2, like means like oxygen bound to itself. That's a molecule. not a compound. Compounds, they have to be different. And again, they're very close to being similar, but it's a fine point that we just need to touch on. So, what happens now if we take pure substances and we mix those together? Well, then we get mixtures, and the biggest thing about mixtures is that they maintain their properties throughout. So if you have oil and water, the oil's still the oil, the water's still the water. They still have their properties. They're just mixed together, kind of like vinegar or oil, like if you have it on salads. Now, there are different types of mixtures. Homogeneous means it's the same throughout. Heterogeneous means it's unevenly spread throughout. We cannot find any foreign objects whatsoever. Solutions is a form. It has a solvent like water and a solute like, for instance, salt. They're evenly spread out. If you take a look here, this is a sports drink. Okay, this sports drink is actually a solution. There's red food dye in there. It's actually red 40, and I can't tell by looking at it that if there's more red on top or more red on bottom. Now, sometimes when you make your own, where you mix your own powder, then it can, there is more stuff on bottom because it didn't mix evenly. And there's a huge amount of chemistry in solution chemistry because we have to move the chemicals around somehow. And typically we do it, and water is an incredible solvent. We'll probably spend a whole chapter on that. Now, if heterogeneous means it's unevenly spread throughout, think of like concrete where you can see the rocks in it, or I think of like chocolate chip ice cream. Now, there are two types of heterogeneous mixtures. And again, mixture, these are always cases where we take pure substances and put them together. Could form a solution or could form a heterogeneous mixture. For a heterogeneous mixture, we have suspensions. Suspensions is where you can clearly see the particles. Again, think of ice cream with chocolate chips or something in it. Now, colloid is a little bit different. A colloid is where we can't quite see the individual particles, but we know that they're there. They reflect light, and they do something called the Tyndall effect. Okay, so an example of a colloid I happen to have here. If you look right here, this is a cup of water with a little bit of my wife's favorite creamer that she has with her coffee. This is a laser. Okay, I'm going to take the laser, and you can see here. I know it's hard to see, but it's tough to see here. But you can almost see, like, you see the beam bouncing around in there a little bit. That means that that this is a colloid. It's really kind of lighting up. This is a colloid. Check out to the bottom there. Yeah, you can almost see it right there. Yeah. So, but anyway, you can see it's kind of like when you're driving and it's foggy outside, and you turn on your headlights, and you can see your light beams in there. That's an example of a colloid, and both of these tend to settle out. Okay, so don't forget, for your guided notes, come up with the word. These are the words in red. I'll have the link in down below in the notes. Make sure to have the word, the definition, and example. Thank you very much.